Alright, so for this video we are going to talk about ions, something that is very important in chemistry. They really become a driving force, and you'll see why later in the course. So to put it very simply, an ion is just an atom with a net electrical charge. Okay? So normally, as we've been talking about before, the number of protons in an atom has been equal to the number of electrons. Because we've been saying for an atom to be neutral, protons have to equal electrons. Well, that is not always the case. Okay? In fact, often the number of electrons in an atom does not equal the number of protons. Okay? Atoms can lose electrons or pick up some extra electrons, and this causes them to have a charge. Now we have two types of ions. We've got cations, which have a positive charge, and anions, which have a negative charge. Now, in cations, the number of protons is greater than the number of electrons, which is what results in the net positive charge. In anions, the number of electrons is greater than the number of protons, which results in a net negative charge. Okay? So it's important to remember those two terms as we're going to refer to positive ions as cations throughout the year, and anions are going to be used to refer to negatively charged ions. So taking a look at our periodic table here, something interesting to note is that there are trends with ion formation, just like with everything else in the periodic table. Okay, certain elements typically tend to form certain types of ions. So we're going to talk about that a little bit. All right. So let me draw in our staircase here, just for reference. Okay. So the first thing I want to mention is that the metals, all right, that would be everything on this side of the staircase, including our intertransition metals here. All of the metals generally form cations. Okay, so the metals, when they form an ion, they're going to be those positive ions. On the other side, the nonmetals are going to form anions. Whenever they ionize, they are going to typically form anions. All right, so that's just one trend. But we can take it a step further. We can say that using our periodic table, we can predict the charge that most elements are going to have when they form an ion. There's a pattern they like to follow. Okay, and we're going to use something to figure this out called valence electrons. So before we move on, I'm going to advise that you go ahead and pull up a periodic table so you have one handy. I'm not going to have one on every slide, but I'm going to be referring to it a lot. So go ahead and, if you've got a hard copy, get one out. If not, I would go ahead and pull one up online so you have it to look at as we go. It'll be very important. All right, let's move on. So let's take a look at an oxygen atom here. Okay, this oxygen atom is neutral because it's got 8 protons, like all oxygen. It's got 8 neutrons, and it's got 8 electrons to balance out that positive charge. So we've got a neutral oxygen atom. Now, I'm going to give you a rule here. It is called the Octet Rule. All right? Called the Octet Rule. What the Octet Rule says is that atoms want to fill their outer shell here. You see this ring of electrons? This is called the outer shell, called the valence shell. All right? Atoms want to fill up that valence shell with electrons. Full means 8. Full means 8, which is why we call it the octet rule here. All right? So in order for oxygen to fill up this outer shell, it's currently got 1, 2, 3, 4, 5, 6. It's going to need to bring in 2 more electrons. Okay? So when oxygen brings in 1, 2 more electrons, it's adding negative charges here. So when it does that, it now has a net charge. So oxygen now has a net charge of -2. That will be its charge. Alright? So what this means is when oxygen forms an ion, it's going to need to bring in 2 more electrons to form that ion. Okay? Well, this probably seems kind of random right now. I mean, how do we know that without drawing the structure every time? That seems like a big waste of time. Well, there's a trick to it. See, now I need you to refer to your periodic table. I want you to look at the group number of oxygen, the Roman numeral group. It's in group 6. And if you'll notice here, oxygen also has 1, 2, 3, 4, 5, 6 electrons in that outer shell. That is no coincidence. Being in group 6, oxygen will always have 6 valence electrons when it's neutral. Same thing for sulfur, selenium, tellurium, and polonium, all of the group 6 elements. So being in group 6 means it has 6 valence electrons and needs 2 more to fill that valence shell. By adding 2, it now has a net charge of -2. And the way you write that, the way you write your ion symbol is element symbol and charge. Notice that we write 2 minus instead of -2. So this is your ion symbol down here at the bottom, O2 minus. Alright? So, let's try another example. So let's take a look at nitrogen. Alright? So we're going to try to figure out the ionic charge of nitrogen. When nitrogen forms an ion, what's the most likely ion it's going to form? Alright, so the first thing we want to do is look to your periodic table and find the group number of nitrogen. Okay? It is in group 5, which means it will have 5 valence electrons, just like you see in this picture. Okay? We look at our outer shell and we count 1, 2, 3, 4, 5, just like we expected. So if it's got 5 valence electrons, it needs 3 more to get to 8 to satisfy that octet rule that we mentioned. So we're trying to get from 5 to 8. So it's going to add 1, 2, 3 more valence electrons. Again, each time it adds 1, it's adding a negative charge. So by the time nitrogen fills up its valence shell, it will be an ion with a charge of -3. Okay? So that's what nitrogen likes to do. Let's try another example. So we're going to take a look at lithium here. Alright? So lithium, if we look over on the other side of our periodic table in the alkali metals group, we see that lithium is in group 1, which means, obviously, that it has 1 valence electron, as we can see here in our picture. Again, 1 in the outside shell. So that means it needs 8 more, or 7 more to get to 8. It wants 8, it needs 7 more. So getting 7 more valence electrons is kind of asking a lot. Alright, so lithium actually does not want to do that. It's got another option. Instead of gaining 7 more electrons to fill up this shell, what it's going to do is actually kick out this guy to empty its valence shell instead of filling it. So the option is either to fill up the valence shell or empty it in order to be quote-unquote happy. So lithium is going to kick out its electron, again, resulting in a net positive charge since it now has more protons than electrons. So by doing this, lithium now forms an ion with a positive charge, which we are going to write this way. So here is the ion symbol for lithium. So basically, you can use the trick that we just talked about to predict the charge of any element when it forms an ion, when we call that ionizing. Alright? So basically, to reiterate, the goal of this whole ionization process is to either fill or empty that valence shell. They're trying to get 8 or 0 valence electrons in that outside shell. Okay? And this process, you can use it to predict the charge for any main group elements. Okay? There are different rules for transition metals, which we'll talk about a little bit later if you're in my class. Right now all you need to know is they form cations because they're metals. So that was a really quick and dirty overview of ions for you. Just gave you a few examples, really explain why it happens. If you want more information, I'm sure there's a lot more out there, plenty of examples. If you're in my class, I've got my notes on my website as well with more specific examples, and you can always come in for help. Please like the video. Feel free to comment below. Thanks for watching.